I've received a number of questions on how to do some of the questions on the homework, so I wanted to try to give you guys a little bit of a start on it should you have any problems. So the two problems I wanted to look at were number 10 and number 12. So for number 10 here, we got the system set up. I've drawn a little bit more poorly than the book does, but it still gives you the same general look here. We've got 2 ohm, 2 ohm, 2 ohm, and 2 ohm resistors here. Now, the first thing that you need to do is try to simplify these down by looking at what's going on in here. This one here is definitely in series with this one here. So that means that this 2 ohm and this 2 ohm resistor are the same as saying that we actually have a 4 ohm resistor here. So I'm going to redraw it as such. I got 4 ohms here, 2 ohms here, and 2 ohms here. Okay, now once I have this, what I need to look at is, well, what is this equivalent, or what is this setup showing me? Now, I no longer have anything that is in series, one directly into the other. Everything is drawn so that they are in loops with one another, meaning that they share common endpoints here and here, meaning that these three resistors are in parallel with one another. As soon as you see that these are in parallel with one another and they don't have the same value as each other, we have to go to the other equation for it. So 1 over the equivalent resistance equals 1 over the first resistor plus 1 over the second resistor plus 1 over the third resistor. All right, so 1 over R equivalent equals 1/4 plus a half plus a half. Half plus a half is 1. 1 plus a quarter is 1.25. 1 over R equivalent. Now, some people stop here. They see that and they figure that's our answer, but that's 1 over our answer. So what we have to do from here then is to look at what the actual answer would be. And what we have to do is take the inverse. So if you have a calculator that has a 1 over button with it, okay, now see how this one here has this 1 over button right here? All I have to do is type in my number, 1.25, and hit 1 over, and I got my answer. So all of that garbage put together is the equivalent of a 0.8 ohm resistor set up there. That's all it's asking you for. Now, the next one that I want to look at, because 11 is really similar to 10, just a little bit different of a setup, a little bit different of a picture. The next one I wanted to look at was question number 12 here, where it asked us, find the current in and voltage across the 10 ohm resistor as shown. So if I'm looking at this 10 ohm resistor, the problem is it's not going to share the same current as everything else in this circuit. The current's going to come from the battery, go to here, and split. Unlike the practices that we've done already, this is not going to split evenly. Some of it is going to go here, some of it's going to go here. And because electricity is looking for the path of less resistance, more of the current's going to go down here than will go here. Now, that current will come back together, and then all of it will travel through this 5. Now, what I want to do here is I'm going to use the Kirchhoff's loop rule in order to try to get this figured out. But to start, what I want to figure out is how much current is actually coming out of this battery. And to make my life easier here, I'm going to simplify this entire setup down. So this garbage right here would be the same as saying 1 over R equivalent equals 1 over R1 plus 1 over R2. So in essence, I've got 0.1 plus 0.5, which is 0.6. Take my calculator here, 0.6, 1 over, and it's going to give me a lovely 1.6666667 as that resistance. So this garbage simplifies to 1.67, and it's going to then be in series with this 5. So that's saying that my total equivalence of this circuit is going to be having a 10 volt battery pushing through 5 plus 1.67 is 6.67 ohm resistor. So I can use Ohm's law to figure that out. V equals IR, 10 equals I times my 6.67, divide 10 by 6.67. I'm going to round that to 1.5. So that tells me that 1.5 amps is going to leave my battery. It's going to split a smaller value here, slightly larger value here, coming back together to form 1.5 amps come back through the battery. Now, to do Kirchhoff's loop rule here, all I care about is this 10 ohm resistor. I don't care about the 2. So what I'm going to try to do here is create a loop that is going to go through that 10 and bring me back to my battery. This is the loop that I'm thinking. If I go here, up through this top branch, through that second resistor, and back. So, the voltage around any closed loop will always be 0. I have one source of voltage, which is going to be the 10 volt gain that I have, minus I times R. I don't know this current, I'll call it I2, times my resistance being 10, minus, well, I technically know this current going through this resistor. It's got to be this 1.5 amps. It's the total that came out of the battery. It's got to be the total that comes back into the battery. So therefore, it's going to be my 1.5 amps times my 5 ohm resistance. So 0 equals 10 minus 10 I2. 1.5 times 5 is going to be 7.5. 10 minus 7.5 is going to be 2.5 minus 10 I2 equals 0. Subtract 2.5 from both sides. Dividing by 10, or I'm sorry, dividing by negative 10. My I2 is going to be 2.5 over 10, or 0.25 of an amp. A lot of work for a little problem, but it's not all that challenging. You just need to know how to combine the resistors together and work your way through it from there. If any of you guys are still having questions, I'll be available for the Zoom on Thursday, and we'll see what else we can do. But good luck, and let me know if you have any problems.